Hello, this is Julie Lerman.
And this is Steve Smith. In this module, we're going to wrap up our course on Domain-Driven Design Fundamentals by showing how we can reap the benefits of our design when it's time to add additional functionality to the system.
In this module, we'll first review our current system design and see how it incorporates DDD patterns and practices. Then we'll circle back to our customer, Michelle, to see how the new vet clinic appointment management system is working out.
During that quick conversation, we'll learn about a new feature, and we'll show how we can implement that feature.
We'll leverage message queues to implement this feature, so we'll definitely be sure to share with you some of the basics about message queues before we show you that code.
The main benefit of our design choices is the ease with which the system can be extended and maintained in the future, and we hope you'll agree that adding to the current design is quite straightforward. So far, our system is pretty simple, though it's fairly complex as most course demo apps go.
The system is currently 2 different web applications, although the user interface makes it look like a single app. Our main focus has been the application used by clinic employees to schedule appointments. There's a lot of complexity with scheduling, so this benefited from domain-driven design. There's also a clinic management application that's used to do simpler data in, data out tasks like record keeping and maintaining information about doctors, clients, patients, and more. Let's review the scheduling app a little more closely.
We have a single aggregate for a schedule, which contains a number of appointments. We limit access to the schedule through the Schedule Repository class, which is responsible for retrieving and storing the schedule in our database. We've identified a couple of value objects that allow us to better model concepts in the domain, and we're making use of domain events to allow our domain and other parts of our system to respond to changes in the state of our model.
It's taken us a while to get to this point, but now that we're here, the design of the system is very clean, and it reflects the customer's domain as well as we've been able to model it so far, of course, given some time constraints.
Yes, we do have to ship this course, at some point.
Right. Of course, as we build on this application, our model would continue to evolve, but we've shown you techniques you can use to ensure that you can grow the application without being overwhelmed by the complexity you're trying to model.
Actually, as it turns out, the customer does have one more request for us. She said something about customers forgetting their appointments. Let's have another quick conversation. As it turns out, the customer does have one more request for us. She said something about customers forgetting their appointments. Let's have another quick conversation.
Hey, Michelle, great to see you. How are things going with the new scheduling application?
It's been fantastic. We're really able to see very easily who's scheduled each day and book new appointments and move things around as needed. And the front desk folks really appreciate that it highlights the appointments that are conflicting or confirmed. That makes it much easier for them. But one thing that's still a problem is the fact that sometimes our clients forget their appointments. It probably happens at least a couple of times every day, and our staff really don't have the time to call every client to make sure they remember ahead of time.
So you'd like the system to call them then?
Well, we understand there's services that'll do that sort of thing, and we might move to that eventually. But for now, if we could just send an email, that would probably help remind clients to put it in their calendar.
Oh, okay. So do you want an email to go out when they schedule the appointment, or on the day before they're scheduled to come in, or maybe even both?
Oh wow, if we could do both, that would be great. One to let them know when they've booked, so that they know that we've got it in our schedule, and another one to remind them that they have an appointment the next day, just in case they forgot.
That shouldn't be too hard. Our model already handles certain events that occur, like when appointments are scheduled, and appointments already support being marked as confirmed, too.
Sure. And I think all we really need to build that'll be new is some kind of service for sending the emails and some way for clients to click a link in the email so they can confirm the appointment. Since it's email, it shouldn't be a problem to send these out the day before, even if that day isn't a weekday or a work day, right?
No, I think that should be fine. It shouldn't hurt anything to send an email on a Sunday or a holiday. And of course, we'll ask our clients to opt into these reminders so we're not sending anything unsolicited.
Sounds good. We'll get started and should have something for you to review real soon.
Before we get into the gory details of the implementation, we just want to make sure that you understand the very high level of what we're doing here. The first thing is triggered when the appointment is scheduled. And in response to that, our system will send a confirmation email to a client.
Once the client gets that confirmation email, they can click a link to confirm that they're going to make it to the appointment, and the system will then mark that appointment as confirmed so that on the schedule, the staff will see that it's got a green box around it and they should expect the client will actually show up.
What's nice about this implementation is that it benefits so much from a lot of the infrastructure we already have in place. And thanks to our DDD-based architecture, it's just as easy to add in a few extra features that we need to make this work.
So as we go through this, you'll see us using some existing and some new domain events, some application events, a number of event handlers and services. One new tool you'll see is something we haven't talked about yet, messaging queues, to communicate between separate applications. The application we've been working with will need to communicate with a public website that the customers will interact with when they confirm their appointment.
Before we go any further, we did just mention something new, which is message queues, and we just want to talk about that a little bit. It's a pretty advanced topic for this fundamentals course, so we're going to talk about it at pretty much a high level.
Message queues are nice to use between applications for a number of reasons. They can help decouple them and make it so that one of the applications can just drop off something into a message queue and continue on with its work and not have to worry about what happens to the message after that.
Right, or if whichever application or applications it's trying to communicate with, it doesn't need to worry if that application is available and listening at that very moment. The message can sit in the queue, and when the other application is ready to grab it, it does. With a message queue, we're really just dealing with a single message. One application drops it, and the other one takes it, and then the message is gone.
Yeah, and there's lots of different implementations of message queues that you can find online. Some of them are free. Most of the cloud services that are out there now have these types of things built in as well.
And what we're doing here is dealing with a single message at a time in something of a silo app, since we control both applications that are communicating with each other. But sometimes you need to have a lot more flexibility than that. You might actually have a number of applications that are interested in that message, and you may not even know in advance or control those applications. So this is when something called a service bus comes into play.
Right. So you'll frequently hear about something called an enterprise service bus, and there's, again, a number of examples of these that you can find available. It usually sits on top of message queues and other features, and one of the responsibilities it has is making sure that messages get delivered to the different applications that care about that message.
It might even be an application that didn't even exist or you didn't know about when you were first setting up the message queue. So even at that point, because Service Bus allows you to decouple the routing of the message, it's possible to go ahead and hook up other applications to listen to the queue.
Right, so you'll see in our scenario that we have our scheduling application raising an event that an appointment was created. And it might be that maybe in the future we would want to add some other application that wants to react to that event.
We could publish it to social media. Hey, I'm going to go see the vet.
Exactly. If we had a service bus, we could simply wire up in our service bus for this new social media notifier service, pick up that event. But with just message queues, as you'll see in our implementation, we would have to change our scheduler application to know about this new app and write to its queue, because we don't have any advanced routing. Everything's hard-coded in our simple scenario. The message queue we are using is RabbitMQ. It's a mature, open-source message broker that you can get set up and running with zero install by using a pre-built Docker container. It has a lot of capabilities, but we're keeping it simple and just using it to define a few specific queues, which our separate bounded contexts will use to publish and consume events.